Hello, welcome to the second episode of our series Securing Cyberspace. I'm Friederike, Editor-in-Chief of the Cloud Report, and I'm of course joined by Juland, Chief Cybersecurity Officer at Cloudical.
Hello,
And
good evening.
last time we talked about security, but we ended at the point where we defined the differences between data or information security, IT security, and cyber security. And the cybersecurity area is located or is combined with cloud computing. And that's why we are talking today about cloud computing. Maybe we start with what is cloud computing?
Sure. This time I prepared some slides.
Great.
So I will use them in a kind of spontaneous way. So I hope you can see my slides.
Yeah,
So
perfect.
as you said, yes, last time we talked about security in general terms and cyberspace. We are focusing on cloud computing, and it is our duty to introduce what is cloud computing or what we understand about cloud computing. And what we understand is we base our understanding in, let's say, a formal definition that is in practice broadly accepted, which is by the National Institute of Standards and Technology, defining cloud computing as a model which enables ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. And those can be different resources, servers, storages, application, and so on and so forth. These resources can be rapidly provisioned and released, meaning that when you need some, you can get as much as you want, you can scale very fast, and if you don't need them, you can release them as fast as possible. And all this should happen, let's say, with very minimal management effort. So you don't need to go to the processes which you have been through in your traditional IT environment. And also you don't need, or you try to have a minimal interaction with a service provider. NIST further defines cloud computing by describing 5 essential characteristics, 3 cloud service models, and 4 cloud deployment models, which I will introduce in shortly. However, to be a little bit provocative, I would like to also say that, well, practically, in terms of security, we would say that cloud computing, independent of the nice definition that we just heard and the nice feature and also the characteristics, models, and deployments that we will learn in a few seconds, in practice, this is somebody else's computer that you use over the network. And what I mean by that, so I don't want to scare anyone, but this is how it works in the practice. You have your client from which you access some machine or some application over the network, and this is running in the cloud, or in a sense, the cloud is practically a data center where something, a PC or a computer is in there and is providing services that are running. So where the services are running and where the data is stored, it's not your local machine, it's some other machine that you can access over the network.
Great. That were a lot of content in a short time, but you promised to go more into detail and say something about the models and the technical stuff. Please go on.
Sure. Yes, so I wanted to talk about the characteristics, which I'll play a little bit around with the slides. I hope this is okay, not too much confusion. So these are the characteristics. When we, independent of the definition, when we talk about cloud computing, we need to think if we find these characteristics in there. So we really are talking about cloud computing. And one of the characteristics is on-demand self-service. There are also others, which is broad network access, resource pooling, rapid elasticity, measured services. which are the 5 defined by NIST, but there are also others defined by, for example, the Cloud Security Alliance, which says that, for example, service-oriented architecture is a prerequisite when we talk about cloud computing, as services are usually provided via RESTful APIs over the network. But the cloud computing should be multi-tenant capable, as this is something that probably is being used by different users, or even from the same, with the same goals or with not the same goals, and can be from the same company or not. And pay-per-use model, meaning that you pay only for what you use. I'll only say some words about a couple of them. For the others, please refer to the NIST standard, and you will find everything that what I'm actually telling today. So the first one, on-demand self-service, it means that a consumer, so you, the cloud user, can literally provision computing capabilities. So you can, from your side, you can use those resources, as we said, so you can rapidly get those provision, these computing capabilities, and this can be different. You need a server, you need an application, you need a database, you need storage, you need networking, whatever that can be used or computing as a computing resource. You can provision this from yourself, so you don't need to contact any service provider or go through some management processes. The next one is the broad network access. And this is a capability that all these services, as we maybe said many times right now, are accessible over the network. And they should be accessible over the network via standard mechanisms which allow you to use, to be kind of platform independent, because you don't need to install any clients on your machine. You can access them from any client you are using, meaning even if you're using a mobile phone, or if you use a tablet or a workstation, and so on and so forth, or you're just your laptop. And with that, to access those services, you would need the web browser. So we are going to a kind of a thick client, as you would say in traditional IT, versus a thin client rather than a thick client, where a thin client is something that you don't have any additional application except of your web browser, which you need to use all the services out there. While a thick client would be some that you have already installed all the different applications that your employee maybe wants or needs to do their job. Another one is what I wanted to say. So give me 1 second, because I need to. Yeah. So these are the others that I want to talk is. As I said before, service-oriented architecture. So this is something that we say it's a prerequisite. Multi-tenancy, I already said, and pay-per-use model. So the service models I have here in place. I hope this picture is not a little bit too much information, but let us start from the bottom. So the first service that it is defined, it's infrastructure as a service. And this is the capability to provide the consumer processing, storage, networks, and other fundamental computing resources, which we see on the left side of the picture. Like you have virtual machines, so if you need computing power, you have storages, you have networking, you have firewalls, and so on and so forth. Who is working actually on this layer? So usually from an employee perspective, it's working, the employees, your employees, your employer, which are architects, which do the architecture of your infrastructure and which operate the infrastructure. And they can deploy and run anything they want on top of that infrastructure. So the next level is the platform as a service. And on the platform of the service, the capability to provide consumers to deploy into the cloud infrastructure, either both applications or own created and programmed applications using different programming languages or libraries or tools which are already there, given by the provider. So this is something you would need to understand which of the providers has maybe the platform that I need for my specific use case. And you will differentiate between the different cloud service providers maybe on this layer. Who is working there? They are working your developers and your testers. Are developing an application, or you are want to use an application and you need to test maybe functionalities, and you can deploy any application you want on that level. And the higher level is the software as a service, which is probably most broadly known to the people out there. Is the capability to provide consumer using applications which run on the cloud infrastructures. And these applications can be any application. Like I put here, for example, the Microsoft Office suite, some machine learning algorithms, machine learning, artificial intelligence services, databases. You can use Kubernetes, vanilla stack, let's say you can use if it's already installed. So you can use whatever you want, and who is working there, it's your users, which are just using those applications. That these applications can be also whatever account management or your client, let's say client relation management software is running there, and they are accessing that. They are putting into their credentials, accessing the software and doing their daily job as they would do this in an application installed on their own machine. So these are what they are defined by NIST. Nevertheless, you would maybe listen or have already listened to terms like X as a service, which means everything is a service, like data as a service. But these are, let's say, the major differences that you find in cloud computing, and everything else, all these X's as a services, by definition would fall in one of these three categories. These were the services, and what are the deployments? Well, deployments, let's start by the private cloud deployment. What does this actually mean? So it's nothing else as you would have all your computing services in your data center, and you are providing the services to your employees via the network. So all the computers are in your data center. These services are provided within your intranet. However, you are not installing these applications, or you are not building the architecture by single machines, but you are doing this via the network on the cloud level. This is when it is on premise. It can be also outsourced, meaning that you would have all this in someone else's data center. So let's say a big data center, which it hosts many different, let's say, clients, and they would provide professional services when it comes to access control, physical access, physical security. They would give you professional services when it comes to, let's say, natural catastrophes. So if whatever, an earthquake and so on and so forth, they would replicate the data to a second twin data center. So this is something that you can have, of course, and you would access this again over the network. So this is what it is. But maybe to make the point here, private means that all these services are exclusively used by one organization, by one entity, but within that entity can be different departments, right? So that access the service, but it's only one entity, one organization accessing the services. Public, well, public means that everyone can use those services. Yeah? There are many public clouds out there, like they say Microsoft Azure, Google Cloud, Open Telecom Cloud, OVH Cloud. So what else do we have? AVS we have out there. So these are the public clouds where all these services, all the different services can be accessed and used by the general public. So you are sharing those with everyone. That's why think about it again, this multi-tenancy capability that needs to be their characteristic. So we talk about cloud services. Another one is community, which can, again, as the private, can be on-premise or outsource, but this is only the on-premise. The outsource, I'll show the next picture, but the idea is here that you don't have any more one organization accessing those services and don't have the other extreme of having everyone accessing those services, but something in between, maybe some organization that have specific needs, that they do need specific services, and therefore they have maybe common concerns and goals. So they kind of agree to build a cloud together and use the services via the cloud. So this is the difference between them. And yeah, so this is, again, you can have outsourced, or this is lying in the network of some of the one organization that is involved into providing those services. Let's say, for example, the ESA, which is the European Space Agency, and the NASA, which is the American Space Agency. They probably have similar concerns. They do have similar goals, and they want to, let's say, for example, they need specific implemented algorithms and services which are not very useful to the general public because they are so specific to their goals and to what they aim to achieve in their daily work. So this is why, for example, these services wouldn't be in a public cloud or only in a private cloud, but maybe in such community clouds that bring something to the general public afterwards. The next one is the hybrid, which is nothing more than just the combination of at least two of the different what we said here.
Great, thank you. I think we got a great and deep overview about cloud computing, but we are talking about securing cyberspace. So what are the security challenges for cloud computing?
Yes, I'll say something about it, and I'll want to jump again to this other picture, which maybe a little bit scaring over somebody that sells a computer. But I mean, this model is very, very simple. But with this model, I just want to make the point and say that even in a very simplified model, we need to think about many things of security. So it's different layers as we already introduced security, and there are also different approaches that needs to be here, different dimensions that we need to take into consideration. And if I use this picture just to guide you through that, well, the first challenge is to make sure that the client that Alice is using in this picture is trustworthy, so that this client is not manipulated, and everything that Alice is inputting, her credentials, things that she is being shown on her screen, that this is not being captured by any malicious actor there. The next one is, if this is the case, how can we ensure that this is, for example, session restricted, so that data that is leaked, it only concerns a specific session? So if Alice accesses those data in the next session, in another session, say by another machine that is not manipulated, the attacker wouldn't be able to access these services again with what the attacker gained at that moment, right? Um, Another one is how can we make sure that, for example, Alice is connected to the correct server, to the correct service. So this is something that it's not only, so all of these, what I'm saying, I just want to make the point that if you think about it, these are no new challenges. So these are challenges you also have in the traditional IT, right? So this is what also one of the points that I want to make here. So this is how you make sure that Alice is talking to the right server. This is something that, well, there's much research out there how you can do this. Another one is that how to ensure that the Alice is connected to the trustworthy service, so that the service it connects in Alice is trustworthy. So even though it is the authentic service, so we are talking to the right server, but how can we make sure that this service is trustworthy? So both of these sides, maybe you can connect them as with the so-called term of zero trust principle. So think about it. So these are principles that play a very important role in this space. Again, as we talked about the trustworthiness of Alice PC, we talk about the trustworthiness of the PC we are connecting to on the cloud, and there we also want to make sure that this is also session restricted, so that if something goes wrong in a specific time, this shouldn't affect the future. This should be as much restricted, as limited as possible. Next one is how to ensure that the remote computer that Alice is accessing can be accessed only from specific networks or machines, making sure that this is not accessible by everyone, right? One that you would think maybe from the beginning is, okay, so even in the network, so how can we make sure that the communication link is secure against eavesdroppers or even man-in-the-middle attackers that are trying to hijack the connectivity? How then can we make sure about the authorization so that Alice is only to authorize is authorized to access only those services that she is eligible to, and she is not escalating privileges, and she is not using and looking into the data of her colleagues, employees, and so on and so forth. Other ones is how can we ensure that Alice behaves securely, right? So she is aware, she's security aware, and she behaves also security. So all of these are not different from the traditional IT to the cloud services, even though in the cloud services, I said, you have a different threat model as this computer is not only on your desk, but is in a data center out there, and you need to think about how can we secure this together, how can we work together with the cloud service provider in order to achieve the security that we want to achieve there.
I'm so happy that we will talk about all these topics again during our series, but for now you just mentioned traditional IT. What are the differences between traditional IT and cloud computing?
Yes, so if I may, I want to go in here. So this is what we have, let's say, as a responsibility model, what I was aiming or what I was striving to and going to with what I was saying just before. So on the left side, you have the private cloud. Meaning what it means, the private cloud, it means that this is, you are responsible for the whole stack, the whole, starting from the hardware to up to the users. All of these can also be in private cloud, like infrastructure as a service, platform as a service, software as a service, but you can think about it as also in the public cloud, right? So the left one can only be in a private cloud. Or let's say in a very dedicated virtual private cloud in a public cloud, right? So there are many mixes, but the idea is here from responsibility level that you should be responsible for the whole stack. So you would need to take care of all of the challenges that we just talked before, and there are many more, of course, you are responsible and you have to take care of all of this. If we go in the infrastructure as a service, if we remember the other picture also, and we recall this in our mind, we see that the cloud service provider is ensuring us with security features and security mechanisms, starting from the physical security, because this is lining their data centers, up to the virtualization level. And from the operating system level and up to the application, the cloud service consumer is responsible for making sure that all the challenges that we said are addressed adequately. If we go to the platform as a service, up to the runtime, everything is secured by the cloud service provider. They are taking the responsibility. Nevertheless, you need to be responsible of what kind of data you are putting out there. The application that you are installing maybe on the platform might have some exploits. And so the cloud service provider is not responsible if anything goes wrong in that situation. The right side is software as a service. Even though I'm not very happy with this picture, maybe the application side should be kind of half green and half blue, because even here, even though you are not deploying the application, so there the cloud service provider is responsible that this application is patched, that this application has no 0 days or exploits, and make sure that you that this is not being used to be hacked and to get into your data that you are storing there. Nevertheless, you are providing access to your employees, so they are accessing. So if you don't store your access credentials in a secure manner, anyone would be able to access this application and impersonate you and get access to the data that you are storing there or that you are processing there. Yeah. So
in the end, you are responsible for some things. It doesn't matter which model you are choosing. So security is one of the biggest challenges of cloud computing.
Well, it is one of the, in my experience, and also from the experience that we have had in the, well, cloud computing kind of emerged and is being now used everywhere, also due to our current situation, is something that it provides us many advantages for doing work from home and being flexible and dealing with even difficult situation that we have, but showing us that things are possible, giving us an opportunity. We should see things like as opportunity as well, and not only as a threat. So, and another concern out there, in addition to security, is of course vendor lock-in. So this is my kind of takeaway, and this is why we would love to talk about open source in the next session, and Frederica would say a little bit more about that, and we would have someone as a guest.
Yeah.
Yeah, the cat is always a welcome guest in our series.
Yeah. Yeah, thank you for mentioning vendor login. Yes, you're right. That leads us directly to our next session, where we talk about open source, what that means, what is connected with the security in open source. And yeah, we will explain what is vendor login and why this is a big challenge in the cloud computing. So thank you very much for the deep insights.
Thank you, Frederica. See you next time.
Yeah.
Bye.
Bye.